Today we're looking at section 9.7, special right triangles. We're going to have the measurements of the angles of the triangles, one side given to us, and from that we're going to be able to find all of the missing sides. This section has practical applications to when you continue on in your math career and we look at trigonometry. So from this slide right here, 45, 45, 90 degrees, we know that there are two 45-degree angles, so it's isosceles, and we have a 90-degree angle. Both these triangles have that characteristic. Looking at our sides, we'll notice that across from the 45 degrees are the same measurements, 7 and 7. Across from the 45 are the same, 15 and 15. The hypotenuse looks almost the same, except there's a root 2 on the end. So it seems to me like the ratio for 45, 45, 90, we have the two sides that are the same. The hypotenuse is the side times the square root of 2. Same thing for this one, 15, 15, 15 root 2 is the hypotenuse. 30, 60, 90 is a little bit more complicated to look at because there's three different measurements. It's not isosceles anymore. We have a 30-degree angle. Across from that is a 5. Across from the 60 is the 5 root 3. And across from the hypotenuse is 10. For the other triangle, we go across from the 30. We have 8. And across from the 60 is the same 8 times the square root of 3. And across from the 90 is that same 8 times 2. So the ratio of the sides here, we know that this one is going to be your x, this one will be the root 3 times the side, and this will be 2 times the side. So we can kind of summarize this in a table here. If we know that we've got a 45, 45, 90 triangle, the sides that are across from the 45 we're going to call x, the hypotenuse we're going to call it x root 2. So if we know, for instance, that maybe this one is a 3, this one's 3, and this would be 3 root 2. 30, 60, 90, same idea. Maybe that this is 4. The side across from the 30 is x. That's my 4. Side across from the 60 is the side times the square root of 3. And the side across from the 90 is 2 times my side, or 8. Now we're going to start with some basic ones. We're going to look at more complicated ones in class, but this is kind of the basic idea of what we're looking for. We're going to find the missing sides and leave our answers as reduced radicals where appropriate. So that we know this is a 90 degree, a 45 degree. This one would have to be 45 degrees because of the fact that all the angles have to add up to 180. So I know immediately that I have an isosceles triangle. Across from my 45 is my x. So I call that x equals root 10. So if I set up my chart, like we did in the setup there, 45, 45, 90, x, x, x root 2, I know that the side across from 45 has got to be 10, so that one's also 10, and this would be 10 square root of 2. So my missing sides are 10 and 10 square root of 2. Unlike Pythagorean triples, where Pythagorean theorem was always a backdoor way to do it, you can always just kind of go through and find a squared plus b squared equals c squared. There really is no way to do it in this case. The only other way you could potentially do it, if you know it's a 45, 45, you know that this side's going to be the same. You could use Pythagorean theorem to find the missing side. But you'll find out in the next example, when we look at 30, 60, 90, that won't work. So here we have a 30, 60, 90 triangle, and I have the side across from the 12, or the hypotenuse, sorry, the side across from the right angle, which is the hypotenuse, and it measures 12. Now my missing angle here is 30 degrees, and I know that because 90 plus 60 is 150, there's 30 left over. So setting up my chart for 30, 60, 90, across from the 30 is x, across from the 60 is x root 3, and across from the 90 is my 2x. So I'll fill in the information that I've got. I know that the hypotenuse is 12, that's my 2x. Well, if 2x equals 12, then x has got to be equal to 6. So the side across from 30 will be 6. The side across from 60 will be side root 3, so 6 square root of 3. So 6 and 6 root 3. Now unfortunately there's not really a quick easy way to work your way through Pythagorean theorem on this one. If you do happen to remember the 30 and the 90, or maybe you know the 30 and the 60, you can find the other piece using the two sides and getting there. But if you're spending the time to do that, then it probably would have been better spent just memorizing that third piece of what we're going to do. So those are the basic ones where the sides are going to be whole numbers, and that part that we have to multiply by root 3 or root 2, no major issues there. In class, we're going to look at what happens when we have a side that's